Imagine standing on the edge of a gorge so deep that clouds drift beneath your feet. The wind tears at your clothes, the ground, if you can even call it that, and is over 1,000 feet below you. And somewhere in this savage, frozen wilderness, a team of engineers decided to build a bridge. Not just any bridge, the highest railway bridge on Earth. A structure so audacious, so technically mind-bending that even today, experts call it one of the greatest engineering feats in human history. How do you anchor steel into a mountain that doesn't want to be touched? How do you build something meant to last centuries in a place where nature destroys everything it touches? Stay with me, because what you're about to hear will leave you absolutely speechless. The Chenab Railway Bridge in the Himalayan region of Jammu and Kashmir, India, is not merely a bridge. It is a declaration of war against the impossible, stretching 1,315 meters from end to end. It soars 359 meters above the Chenab River. That's 35 meters taller than the Eiffel Tower. You could stack the Eiffel Tower beneath this bridge and still have room to breathe. It is part of the Udhampur-Srinagar-Baramulla Rail Link project, a 272-kilometer corridor designed to connect the Kashmir Valley to the rest of India by rail for the very first time. A region isolated for millennia, cut off by avalanches, snowstorms, and sheer vertical rock, was finally going to be stitched into the national fabric. But to get there, engineers had to cross the Chenab Gorge, and the Chenab Gorge had other plans. This part of the Himalayas is not a gentle landscape. It is a battlefield. Temperatures swing from minus 20 degrees Celsius in winter to scorching summer heat. The terrain is raked by earthquakes. The region sits on one of the most seismically active zones on the planet, where the Indian tectonic plate slams into the Eurasian plate at 45 millimeters per year. Hurricane-force winds funnel through the gorge with terrifying velocity. The rock itself, a chaotic mix of shale, quartzite, and limestone, can shift, crumble, and collapse without warning. Landslides here are not rare events, they are a routine fact of life. And yet the project pressed forward, because leaving Kashmir disconnected was simply not an option. Planning began in the early 2000s with a map and a problem. Engineers from Konkan Railway Corporation needed the narrowest, most geologically stable crossing point over the Chenab River. Satellite imagery was studied. Teams of geologists literally rappelled down the gorge walls, drilling core samples to understand what lay beneath the surface. What they found was simultaneously promising and terrifying. The rock on both sides, or the abutment zones, was solid quartzite, hard as iron, and stable enough to anchor the structure. But between those anchors lay 1,300 meters of empty, howling air. The solution was an arch bridge, a design that channels all forces of gravity downward and outward into solid rock. Elegant, ancient in concept, but never before attempted at this scale in this environment. The arch alone would span 467 meters, the longest steel arch in Asia. Blueprints were drawn, computer models were run thousands of times. Engineers from India, Germany, and the United Kingdom argued, recalculated, and argued again. Slowly, a plan emerged, but the real challenge was still ahead, getting the steel to the gorge in the first place. The Chenab Gorge has no roads, no flat areas for helicopter landings with heavy loads. Every single component had to be manufactured elsewhere and carried into one of the most remote vertical landscapes on the planet. Over 28,000 metric tons of steel were required, not standard structural steel, but a special high-yield grade designed to absorb seismic shocks and resist fatigue over a 120-year lifespan. Each segment was fabricated in Maharashtra and Rajasthan, coated in a multi-layer anti-corrosion system, zinc primer, epoxy intermediate layers, polyurethane topcoats, and trucked to the nearest accessible point. From there, aerial ropeways carried steel, equipment, and workers back and forth across the abyss like a slow-motion ballet of industrial machinery. The ropeways themselves were engineering projects. Towers were erected on near-vertical cliff faces. In some places, workers were lowered on ropes to drill anchor holes by hand because no machine could reach that angle. Every meter of progress in this gorge was paid for in pure ingenuity. Now here is where the engineering becomes truly extraordinary. The arch could not be built from the bottom up. There is no bottom. You're only a 1,000-foot drop into a river. Instead, engineers built from both sides simultaneously, cantilevering steel sections out over the void, each segment held not by anything beneath it, but by temporary cable stays anchored to the cliffs above. Imagine two enormous steel arms reaching toward each other across an abyss, suspended like puppets from the mountaintops, inching closer month after month, year after year. The cable stays carried loads of thousands of tons, anchored by 75-millimeter steel cables grouted into shafts drilled 15 meters deep into the rock. As each new arch segment was welded into place, every weld verified by ultrasonic testing, the cable geometry was recalculated to account for the shifting center of gravity. Sensors transmitted real-time data to engineers around the clock. If any cable tension deviated beyond acceptable limits, work stopped. The system was recalibrated. Only then did the next segment go up. The moment the two halves of the arch finally met in the middle, a closure joint executed to millimeter precision after years of work, was described by workers on site as unlike anything they had ever experienced. The gorge was its usual savage, indifferent self, but in the middle of that void, two pieces of steel fit together exactly as planned. A milestone so hard won, it defied the very logic of the landscape. With the arch complete, the bridge deck could be installed, but before a single train could ever cross, every weld, every bolt, every structural node had to be verified. Non-destructive testing teams moved across every surface with ultrasonic probes, magnetic particle systems, and radiographic equipment. Any weld showing even a whisper of internal cracking was ground out and redone. The standard applied here was not commercial grade, it was aerospace grade rigor, because in this gorge there is no margin for error. Wind tunnel tests at the National Wind Tunnel Facility in Kanpur confirmed the bridge must withstand gusts of up to 266 kilometers per hour, the kind of wind that strips roofs from buildings. Sensors now permanently installed monitor wind speed, seismic activity, temperature, and structural strain in real time. An automated system will halt all rail traffic the moment conditions exceed safe thresholds. This bridge is not just a structure, it is a living, continuously monitored system. The human story behind this bridge is as staggering as the engineering. The thousands of workers, welders, surveyors, geologists, safety officers, lived in remote camps perched on cliffsides for years. Shifts were dictated not by clocks but by weather. Work halted when visibility dropped, when winds spiked, when rainfall triggered rockfall risk. And yet, day after day, workers returned to the gorge, strapped into harnesses, and climbed back out over the void. Ask any one of them about the Chenab Bridge, and you will see something in their eyes that goes beyond a job completed. It is the look of someone who did something they were told was impossible, and did it anyway. When the Chenab Bridge opens to full rail traffic, it will transform Kashmir. The valley, cut off every winter when mountain passes vanish under meters of snow, will have a year-round rail connection to the rest of India. Agricultural produce that today rots in trucks stuck in blizzards will reach markets in hours. Medical supplies, emergency equipment, development resources, all of it will flow freely across a bridge built over nearly 2 decades of unbroken human effort. In a place where nature has always held the upper hand, this bridge is the answer. A steel arch 359 meters above a river built by human hands in the coldest, most vertical, most seismically violent terrain on Earth. Not because it was easy, precisely because it was not. And the next time you cross a bridge, any bridge, think about the hands that built it, the minds that designed it, and the audacity it takes to look into an abyss and say, "We will build here."